Well, thank you very much. My name is Mike Haru, and I'm hosting a workshop on scientific software with a focus on developer productivity. And today we have 3 members from the Oak Ridge National Laboratory. Tell me the name of the group, the official name.
Sure, Mike. The official name of the group is Research Software Engineering.
Very good. And that's a very common term now, and especially it was in the UK and for a long time, and now it's becoming much more common in the United States, RSE, right?
Yeah.
So very good. And so we have John Hendrick, Jay Billings is the group leader, Addi Malviya. Did I say your name correct, Addi?
It's Malvi, that's fine.
Malvi, thank you very much. And so we're here to talk with them today. And Jay, I'll start with you because I think you've been around from the very beginning and before the group started. Can you tell us a little bit about the motivation for why the group was started and its scope and purpose?
Absolutely. So the group was started in brief to provide and support excellence in developing scientific software. Many years ago, about a little over a decade now, a colleague of mine named Barney McCabe and I realized that software was becoming critical in the scientific enterprise, and that there's a good group of people who are really skilled and excellent at developing scientific software and taking it to the next level. So we started this by first creating what we called our scientific software initiative that focused on building the community of developers and engineers at the laboratory. Now, we look at these as more labels than anything. So this community had developers and engineers and computational scientists and data scientists and all sorts of people. And eventually it became clear that we needed to go one step further and to support this community by giving it a home and rooting it in a line organization so that we could continue tackling these really big, critical software projects.
Yeah, very good, very good. And so you've been a group now for a little less than 2 years, is that right?
That's correct.
Yeah.
We were a team before that for about 2 years as well.
And how many people are in your group, and what is the breakdown of kind of the skills and focus that they have?
Well, that's a good question. So I think at this moment, I think we're right at 20 or 21 with 5 or 6 people onboarding. And so we have a number of people that by the end of August or so will be on, and then the group will be at 26 or 27. And we're hiring a couple people a month, which is wonderful. We're just growing really fast. Wow. The group largely breaks down into 3 different types of members. So we have members that are more on the computational scientist side, and they focus on kind of application development, computational science, and kind of maybe more traditional things that we might think of in our neck of the woods. And then we have a large contingent of what I'll call card-carrying software engineers. These are people with computer science degrees and strong software engineering backgrounds, and they really focus just on software engineering. They don't focus on science problems, just the engineering. And then the final group of people that we have are our DevOps engineers. I prefer to call them release engineers. They are focused on the platforms and infrastructure that surround the software and help us get it out to delivery. So a lot of our projects are operational in nature, meaning that they support user facilities and they have to be available always. And our release engineers are our secret sauce for doing that. These people work constantly to build our infrastructure, to support the release of our products, and to engineer how we actually execute and deliver that software.
That's very good. I like that term, release engineers. That's a nice term, very evocative, and probably maybe a bit more understandable to a person who's, to whom DevOps is maybe a little fuzzy. So I like that. That's a good term. Very good. So we have a sense now of the scope and purpose of your group. Do you have some specific stories that can help our listeners, our viewers understand what your group does day to day?
Sure. I think we could probably each give you a story.
Great.
I'll let someone else go first. I've done a lot of talking.
All right.
I can talk about a story first.
Very
Um,
good.
so some of the efforts that we are involved in is to increase the productivity of scientific developers, because what
Addi, may I
usually happens.
interrupt you for just a second? Can you tell us a little bit about yourself? I forgot to
Sure.
ask each of you to introduce yourself. So let's do that now, if you don't mind.
Sure, not a problem. Hello, hi, I'm Addi Malviya. I'm a team lead in the research software engineering group. I have joined last year. Before that, I used to work for industry, healthcare, energy. I have worked in all sort of different domains. So I kind of bring a lot of different kind of software experience into the science background here, and it's very, very interesting. So that's a little bit about my background, and I'm currently leading a lot of projects for the research software engineering group. That's where my involvement comes in with this group.
Very good.
So and that kind of, I guess, plays into my example, because as part of some of the projects that I'm leading for our group, what we are helping. So there are a few models. So we are collaborating, like, for example, you may have heard of the Exascale project. So we're collaborating with the scientific developers who are developing these specific science codes to kind of see how do they operate together and independently. They are for the frontier, the upcoming new computers, but by the time we get there, we have to make sure that we are able to validate the software runs together and independently. So that's where we come in, where we take the piece of code where it's running on a particular developer's machine, and then we run it first on a simple computation environment, and then we try to run it in a continuous flow on something that's like a supercomputing machine. So that really helps identify all those problems and dependencies that exist but are not very exposed. So then it forms a nice cycle where you are able to provide feedback all the way up and say, like, hey, these are the dependencies that if we could work on, that would resolve all of our problems. So we have been able to identify a lot of problems and dependencies upfront that we would have seen later when we tried to run these codes together. So I think that has definitely been very helpful, not just for, this is just one example, but for a lot of our other projects where we are involved in.
Very good. Thank you. Yeah. And then, so you essentially are helping scientific software developers, people who know the domain science well, and helping them take maybe a software product that they're working on or worked on, and make it more HPC capable. Or is that a reasonable restatement of part of what you said?
Sure. I mean, we also do that. So what we do is essentially we bring the computational scientists and we collaborate with the domain scientists to get there. So a person in my team, when we help this project, actually takes the codes and turns them into COCOs and C++ and some of those other capabilities, whatever we need to kind of get a particular piece of software there. And they're very mature. I'm not saying that they are not. It's just what is the best way to bring everything together so it's operational.
All right, very good. Thank you very much. Yeah, yeah. Thanks. That's great. And before we move on to John, Jay, let's just clarify who you are, your role in all this enterprise.
Right.
I think I forgot to ask you.
Sure. My name is JJ Billings. I'm the group lead for research software engineering. My background is in computational astrophysics, and my PhD thesis work was in scientific workflows. And so over time, I migrated from more of a domain background into a computational scientist role. And that's where I find myself today when I'm not doing line management.
Yeah, very good. That makes me think about, so Addi, I think you identified domain scientist, computational scientist, and then a software engineer. Are those in your group? Are those the three major entities in your ecosystem? Is there another entity, a type of staff member or type of skill set that's in your group?
I would say that's about correct. If we kind of fold in, like the Jay said, we do have some release engineers. If we fold them into the software engineer umbrella, I would say that's a pretty accurate picture of our group.
Okay, all right, very good. Yeah, okay, thank you.
We
So
also
John,
have
go.
John.
Oh, go ahead, please. No,
I was
go
going to say,
ahead.
we also have John, who's right now, he's a principal software architect in our group.
Very
He
good.
brings a different set of skills to the table that I'm sure he'll tell us about.
Yeah, very good. Yeah. Okay, John, go ahead, please.
Hi.
Yeah, and introduce yourself a little bit if you don't mind.
Sure. Hi, I'm John Hendrick. So my background is in systems and software engineering. I grew up, I have a computer science degree. I grew up in a systems engineering shop in industry, and it happened to be in the aviation industry. So I really cut my teeth early on in very rigorous software development and system development, lots of process, those kinds of things. And and so I've got a good background, rather broad background in that kind of systems engineering and software development environment, and understanding how those two disciplines and environments come together to create a holistic product that one needs. I also have a background in consulting, helping organizations improve how they do software and systems development. And actually, Jay and I worked together about 10 years ago. I was a consultant, and we worked together, I guess it's been about 11 years ago now. And that's how we first met, in going through and understanding that. So there's a lot of aspects there, and productivity, it's great for what you're talking about, because there's lots of ways to do that. There's lots of facets to that. It's not just one thing. And so that's kind of me in a nutshell.
Very good. And you have a specific example of something you're working on that will help the viewers understand the nature of your work?
Sure. Yes. This is actually pretty exciting. We are actually adopting, so we have a project that's ongoing with the Neutron group, and right in support of all the instruments and the science that's going on, and all the neutron instruments. And one of the things that we're doing is to increase our collaboration and increase the flow of understanding of what the scientists need and the instruments have to have in order to be productive. We started to adopt user stories it increases our ability to communicate, and it also feeds our pipeline a little bit better, so that we can manage, both of us can manage, and prioritize what work needs to happen. And that also really focuses the conversations that the software folks have with the scientists and the computational instrument scientists on both sides. So we come together in this collaborative way, guided by these user stories that tell us where to go and how to be most effective. And it really starts to increase our productivity, in that we have this nice streamlined way of doing essentially requirements, which isn't a very popular topic all the time, but it works really, really well, and it facilitates that. And it also, on our side, then lends us very easily into doing, which Jay may talk about, test-driven development, because we immediately have something that we can write a test to, and as we begin to write our software.
Yeah. So there are a number of patterns that are used for user stories. As I need, so that. I think that's one example. Do you try to convey that, or do you allow a more kind of flexible approach? What do you find effective when you work with your users, clients, to develop user stories?
So we do. We adopt a pattern, and it's that exact pattern. I, as want to, so that that's a very that's the pattern that we have adopted. We're pretty strict about, we call it our user story statement. So we're pretty strict about that statement.
Yeah.
But then the other thing we do is, because this is, that's a little terse and uncomfortable for a lot of people. So the other thing we spend a lot of time on is the acceptance criteria. And when we get into the acceptance criteria for a user story, then there's a elaboration of detail in there. The last part that we do also is we have another section that we call additional information, where anything that's relevant that needs to be or wants to be communicated, we say just put it in that section there. And we're constantly going back and forth and reviewing them, and it's an iterative process, right? So we work with the scientists to write these user stories, and then we elaborate on them over a couple of cycles before we actually start our implementation on them. So yeah, we have a structure. It is loose. We like that format to that statement. But then the other sections, as long as the criteria are something that is easy to understand, such that we know, the software folks know how the software is going to be evaluated. That's really what we target in that user acceptance. And then any additional information. And there's a lot of value to having that. And that could be as simple as just hey, we're going to use this calculation and it's referenced in this paper over here. And that's fine. As long as we can have access to it, it gives us the details that we might want as we go further on and communicate about that.
Very good. Thank you. Thanks. Jay, how about you?
Yeah. So
Jay,
these are
do you go
really,
by? Clarify something for me. Do you go by Jay or JJ or both?
I go by both, and
Okay,
so
fine.
I go by either or.
Okay.
One's
All
my
right.
first name, one's my first and middle name. So
All right. Very good. Thank you.
I think both John and Addi call me JJ. I think most people
Right.
I think most
Very
people
good.
these days call me JJ.
Okay. Very good. Happy to do that. Okay. Go ahead, please.
So Addi and John got some really good examples, and so there's one that I really like that's kind of near and dear to me. So as a computational scientist, I'm a methods nerd, methods and algorithms and languages, and those are the things I really like, and I like figuring out how to apply those in new ways and come up with new designs and new architectures. And what I get to do in my job that is really cool from that perspective is to work on modernization projects. Yeah. So right now, one of the places where we're starting to do more work to modernize software is on some older biofuels codes and bioenergy and biofuels. And one of the codes we're working on was actually written in the early 70s and was in Fortran 66 when we started working on it.
Wow. So
it's been really great to start modernizing this project. The first place we started was with test-driven development. And when you're talking about a code that old, what does TDD look like? Yeah. And how do you apply that? And so I like to be able to go back and to take modern algorithms, modern methods, modern processes, and modernize codes going forward. Now we're working on 2 different biofuels projects, and it's really neat to go back into the languages. And for example, how do you use a JSON input file in a Fortran code? And how do you restructure that code so that you can start bringing in parallelism? Or if you can't make the code parallel, how do you set it up so that you can do stochastic modeling runs where you run the code itself many times over in parallel? Mm-hmm. So we're looking at a lot of really interesting questions like that. And for me, as a computational science nerd, I really enjoy those types of projects.
Yeah, that sounds great. That's a very powerful approach to doing things. So we want to keep things short so people will view this. Any other last minute comments, remarks for people?
I have one, but I don't know, Mike, how you would feel, and I guess you could edit this out if you want, if I plugged our group and said we're hiring. And I don't know.
Yeah, go for it.
Okay. And I'll understand if it gets edited, but we're hiring, and so Oak Ridge's research software engineering group is growing, and we are always open to working with new people and doing new things. Language doesn't matter very much. Just
Programming language, you mean?
pretty much any language.
Or any
we
language.
Work in
Yeah.
any language. We work in about 12 or 14 different languages in the group. So
Wow,
if you're interested, reach out.
Yeah. Very good. Thank you very much. All right. Well, we have been chatting with the Research Software Engineering Group at Oak Ridge National Laboratory. Thank you very much, JJ, Addi, and John. I appreciate your willingness to speak with us, and look forward to hopefully others being able to view this over the coming weeks and into the future. Thank you very much.